Power to the Truth. This is Margo. This is Monday, August 27th, 2018. And today I'm going to share a couple of articles with you. The main article is this one I have up here. It's by a meteorologist, Nick Humphrey, and this is an article that he put up yesterday on his Patreon account, and it's public. And Nick Humphrey is a meteorologist that's been studying climate change for a very long time, and he's recently come on the scene. He's been interviewed by Sandy on Environmental Coffee House, and I find him very interesting to listen to, and he's been researching about climate change and brings a lot of things to light for those of us who are not trained. And so this article answers a question that one of my subscribers posed on a recent video, and the question was, since the ice that's up there, or since things are going to refreeze in the winter time, once we hit winter, any little bit of ice is better than nothing, isn't it? And we're good for another year. And then his article came out yesterday, and it was a perfect explanation for that. So my answer to that subscriber was, yes, anything is better than nothing, but that she needed to read this article, because even as I'll just give you an overview of the article, and then I'm going to read it all to you. As the ice melts and gets thinner and thinner, and we lose the old year ice, then we have, and then the like the old year ice is down here above Greenland and Canada, and as we lose more and more of that, this outer ice is getting thinner as well. And so what happens is every year it melts down more and more and more, and so at the end of each melt season we have less ice to start with going into the winter, and then in the spring when the melt starts up again, there's less ice to melt, and so eventually there won't be any ice to refreeze or do anything with up there. And I'm also going to share a blog post from Robin Westenra. I finally learned how to say his name, and this is actually a repost, but he reposted this on Saturday the 25th, and it's a reminder that we had a warm, freakishly warm Arctic weather back in February. It was freakishly warm, and so that set things up for things not being as frozen and all kinds of stuff. So I'm going to go over that too, and I'm also going to show you what what the missing data was from NASA Worldview yesterday, and you're going to see that this area over here that I'm pointing to is still, the coastlines are ice free, and that's where some of that older ice is. So because that part didn't have any clouds, or it had few enough clouds that we could see through. So I hope you enjoyed this report. I found it very educational and was able to understand things a lot better as a result. Okay, so it's called Arctic Sea Ice Extent Threatening a Top 5 Lowest Annual Minimum This Summer. And it was published yesterday, August 26th, by meteorologist Nick Humphrey on his Patreon site, and I'll leave the link below. The sea ice extent in the Arctic may possibly be the top 5 record lowest on record going back to 1979 based on current trends. Sea ice melt has been limited in August compared to July, but given what has already occurred and the abnormally warm Arctic this summer, with the exception of the very interior Arctic north of 80 north, a September seasonal melt in the top 5 is certainly possible at this point depending on ongoing weather conditions. And then there's a picture of the model that he uses for ice. That's the ice concentration. And then he explains the graphs, and he says, above is Arctic sea ice extent and concentration for August 24th, 2018. Note the severe recession on the Atlantic side as well as ice retreat north of Greenland's coast. What classifies as severe? Here's another map with the 1981 to 2010 average extent for the date. So we'll go back up and look at this. So yeah, it's retreated very far in. This is the 80 degree latitude line right here. Okay, moving on. Here's I already know this is from the National Snow and Ice Data Center. This is their model of the concentration. That's as of August 24th. And we know that the more blue it gets, the less concentrated it is. Means it's not as packed in. He says you can also see how severely recessed it is on the Pacific side. Record low extents were noted earlier this year on the Pacific side for the Bering and Chukchi Seas. So here's the Pacific side. And here's the Bering Sea, and Bering Sea is over here, and the Chukchi Sea is over here, up here by Russia. And up here, and this is where that East Siberian ice shelf is. On the Atlantic side, the sea ice extent is the lowest on record for the combined Greenland, Barents, and Kara Seas. August 20th, it dropped to the lowest extent on record, which was previously set in September 2017. So, Greenland. So for the Greenland, and then the Barents Sea is over here, and the Kara Sea is over here. So you can see it's all gone. That's all gone over here on the right, and then it's gone. It's pretty much gone all around Greenland. Atlantic sector sea ice. And this is a graph that just shows the Atlantic sector of the sea ice that they've been charting. And we can see that so far 2018 is the lowest for the Atlantic sector sea ice since they've been charting this. And he explains, the overall sea ice extent is currently following the 2010 to 2017 average, which much below the 1980s or 1981 to 2010 normals. 2018 extent extent is currently the fourth lowest on record for the most recent data, behind 2012, 2016, and 2007. The current top 5 annual minimum years are 2012, that was the record low, 2016, 2007, 2015, and 2011. The minimum is in September, because that's at the end of the summer season, and then the Earth starts tilting back away from the sun. Then they go into night up there. So we can see that out of the top 5 annual minimum years, we've had 2016 and the 2015 very recent, and 2011 is not that far away, and 2012. So this decade we've had the top 4 of the minimum, of the lowest, in 2007. And here's that chart that explains that. Here's that chart. Arctic sea ice annual minimum. He says Arctic sea ice is on a path of major declines compared to not only the modern observational record but also paleo records. The Kara and Barents are currently experiencing their lowest extents in nearly a millennium at least. Here he goes into sea ice thickness. I'm not sure what model he's using here, but we can see this is measured by meters. This was July data, but we've been watching it through August. So at the end of July, the thickest sea ice, which was right around here, which is the area we've been closely watching the last couple of weeks, north of Greenland and these Canadian islands, was about at, it looks like, according to this color, about at 2.5 meters. This is in meters. 2.5 meters. And then it goes down from there, and it goes into the greens, like from 2 down to 1 is you're in the greens, between 2 and 1 meter, and then under 1 meter you're going into the dark green and blues. There's another depiction of it. This is the anomaly, that's the difference. So this is how much different it is, how much lower it is than it should be. And so when you get into this dark blue, that's minus 2 meters, so that's 2 meters less than it should be. And we've got that up here around these coastlines off of Greenland and Canada. And almost all of the sea ice is lower. You can see, because it's in those blues, that where it's almost all of it, except for just a little tiny bit up here and over here. And here is a chart of percentage of Arctic ice in early March. So this was in early March. So this is the percentage of, like, the different ages of ice. So in March they had almost 40% of 1-year-old ice, and then like 40, so about 10% of 2-year ice, about 10% of 3-year ice, about 5%, no, about 10% of 4-year ice, and then about and then you can tell from here. And then the rest was 5-year ice. So less than 15% of 5-year ice. And this was starting in 1984. But by 2018, look at the difference. We had it. Look at the shift where we only have a little teeny tiny percent of 5-year-old ice. Teeny tiny. It's probably like 5%. And teeny tiny bit of 4-year ice, and then about 5% of 3-year ice, and then maybe 10% of 2-year ice, and then the rest is 1-year ice. So that's how it shifted. That's because it keeps, when it refreezes, there's not as much ice to refreeze. And it's thinner. So it says ice thickness along with extent is undergoing significant decline. Hence, ice volume is also on major decline, with 2017 having the lowest annual average extent on record, with the lowest seasonal minimum volume in 2012. The oldest ice, being the thickest, is declining the fastest, and that's what I've been showing everyone. So this map is temperature anomaly 2 meters at the Arctic. So this is the measurement is 2 meters above the surface, within 2 meters above the surface, and here are all the temperature anomalies. Where if it's white, that's 0, meaning it's where it's supposed to be temperature wise. And if it's blue, it's less than what it should be temperature wise. And then when you see the browns and the oranges and the reds, it's going up. Now this is from August the 26th. And you can see that over most of the Arctic it's higher than normal. Even if it's just a little bit higher, I mean, that counts. And see here above these Canadian islands, it's higher than normal. You can see it's about 1.5 going up to 2 there. Higher than normal. And then you can see it's a lot higher than normal over here in the Kara Sea and the Barents Sea, but the Kara Sea especially. And that's, if anyone saw my Novaya Zemlya video, that's where the Russians dumped a whole bunch of nuclear waste and different stuff after the Cold War, and their reactor rods down there. There's a nuclear submarine down there, and my theory is that because of all of the nuclear testing that was done on Novaya Zemlya during the Cold War, that the result of all that nuclear radiation and all of the waste from all of that testing as well has that started up the warming of the Arctic faster than everything else. So you can go back and look at my video on that. But this is the area where all that stuff is dumped, and that's where it's so hot now. So anyway, you can look at that. Okay, now he explains it. 7-day mean temperature anomalies for the Arctic region ending at 6 UTC September 2nd. The drawing in of abnormally warm temperatures from the North Atlantic and Siberian landmass will contribute to further sea ice melt. So, you know, he's talking about the air temperature, but, you know, it's all connected. What this means for climate change and extreme weather. So now he breaks it down for us. As the Arctic continues to tip over into a warm season, ice-free state, the increasingly continuous open blue ocean makes more and more heat accumulating into the climate system. Less ice means more dark ocean absorbing more heat from the sun in the summer, as opposed to white ice reflecting more solar radiation back into space, which would limit warming. The continuous ocean warming contributes to the regional and global rise in oceanic heat content, but also means when the polar night comes, more heat must be released back to the atmosphere to cool the oceans sufficiently to form new ice. This means progressively warmer Arctic winters with later season new ice formation and ice which remains thin through the winter. Then here's another anomaly map. This is sea surface temperature anomaly. So here's he's measuring the temperature of the sea surface, and so you can see, I mean, so many areas are so much higher than they should be. They're way up there, like that black is 8 degrees Celsius higher than it should be. And here's that area in the Kara Sea that I was telling you about, and it's in the black. The very abnormally warm peripheral areas of the Arctic Ocean. The anomalies shown here are relative to 1961 to 1990 climatology to better show the effect of Arctic ocean warming caused by climate change. See, it's changed all. Look at Greenland, how much higher it is. And up here in the Chukchi Sea and over here. Global ocean heat content. This is from NOAA, and this is their graph. Starting back around 1960, and then it's just been going up and up and up. And here we are. We're in the red, and we're off the chart there. Global rise in oceanic heat content in the first 200 meters to 6,550 feet of the global ocean. Approximately 93% of the excess heat retained by the planet is going into warming the oceans. This has been an increasing phenomenon with the later initial ice formations and later extents in the Bering and Chukchi Seas, including prominently in the 2017 to 18 winter. Research also suggests that the rapidly warming Arctic, a process known as Arctic amplification, is contributing to a weakening of the polar jet stream, which dominates mid-latitude weather, leading to a slower and much wavier jet stream. This means areas suffering much greater extremes and much greater swings between extremes. Arctic temperatures. So here's a graph with the baseline from 1981 to 2010, and we can see it's been going up, and here it was in 2010, and we can see how it's just been going up since then. The Arctic has warmed 2 to 3 times faster than the globe as a whole even faster in the deep Arctic, 80 degrees north latitude and higher. This temperature anomaly graph is relative to 1981 to 2010 climatology. The past 5 years, the Arctic annual temperature has averaged 2.5 times warmer than the globe at large. Again, the 2017 to 18 winter was quite prominent in displaying this increasingly powerful phenomenon, with extremes such as the abnormally warm and dry western U.S. versus the abnormally cold Great Plains. Meanwhile, the eastern U.S. saw record heat in February, followed by multiple nor'easters in March. Much of Europe had abnormally warm temperatures early this year, but in March were hit by extreme cold associated with the Beast from the East, a prominent Arctic air mass from Siberia, shunted out of the Arctic as the Arctic underwent a wintertime heat wave with above freezing temps near the North Pole. In fact, the Arctic had its warmest winter on record. Later in the season, the U.S. Great Plains saw a major swing in pattern, with many areas going from one of their coldest Aprils on record to one of their hottest Mays. My city of Lincoln, Nebraska, had its third coldest April on record, followed by the fourth warmest May. Records here go back to 1887. It was also the warmest May on record for the continental U.S. There is evidence that the rapidly warming Arctic is also leading to influences in the summertime atmospheric circulation patterns in the northern hemisphere. The overall effects, as sea ice continues to decline, further acceleration of global warming, Arctic amplification of regional warming, further weakening of the jet stream circulation leading to much greater extreme weather, temperature and rainfall versus drought, as well as swings between extremes. So this is very important phenomenon we must care about. Another impact, a rapidly warming Arctic means accelerating releases of carbon dioxide and methane to the atmosphere, accelerating global warming even more. And loss of sea ice with warmer atmosphere and warmer winds would mean an increased acceleration of ice sheet melt from Greenland, accelerating sea level rise globally. Much for humanity to face in the coming years ahead. Meteorologist Nick Humphrey. And here are his references with links to everything. So I think this article pretty much puts all the dots together and shows what is happening, and then he brings it all together in that last paragraph or so about why it's important, and this is why our weather is changing, and this is why we've got to be prepared, because with all these weather extremes, the crops are going to be failing, and also, there's going to be lots of flooding, lots of droughts. I mean, we're not going to be able to sustain ourselves without food and water. So I thought that was an excellent article. And then here's Robin's blog post, reminder of a winter heat wave in the Arctic. This is a reminder of a winter heat wave in the Arctic in February. Freakishly warm Arctic weather has scientists reconsidering worst-case scenarios on climate change. And this is a video that was from Democracy Now!, and they interviewed Jason Box about the Arctic weather, and he got suppressed for coming out about all of this. Scientists are expressing dismay over unprecedented warm temperatures in the Arctic. In recent days, temperatures at the North Pole have surged above freezing, even though the sun set last October and won't rise again until later this month. Now, this is from February. On the northern tip of Greenland, a meteorological site has logged an unprecedented 61 hours of temperatures above freezing so far in 2018. The record-breaking temperatures are connected to an unusual retreat of sea ice in the sunless Arctic winter. So the sea ice was retreating in the winter. So what does that mean? It means to me that it's melting from underneath. Scientists suggest warming temperatures are eroding the polar vortex, the powerful winds that once cushioned the frozen north. The alarming heat wave is causing scientists to consider even their bleakest forecasts of climate change. According to a leaked draft of a scientific report by a United Nations panel of scientists, quote, "The risk of an ice-free Arctic in summer is about 50% higher," unquote, with warming of between 1.5 and 2 degrees Celsius. We speak with Jason Box, professor in glaciology at the Geological Survey of Denmark and Greenland in Copenhagen. And it's a really good video. I'm not going to play it here because I don't want a YouTube strike. So I'll leave the link below to that. And then I've got NASA Worldview pulled up here. This is from yesterday. I already showed most of this Arctic sea ice from yesterday, but the part that we didn't have when I was doing the report was this area over here. So let's zoom in. And this is some of that older ice and thicker ice that has melted. And we can see, okay, when I overlay the layer where we can see where there's no clouds, we can zoom in. And most of it is cloud covered, so that's why you can't get a good reading just on one day. You can't get a good reading of the whole Arctic. You can't see it because it's cloud covered. This is a satellite view. So this part is not cloud covered, and we can see that this ice is really broken up, but we can see there's no ice over here to speak of in these little cubby holes. And down here, there's no ice. There's no ice over here. And there's no ice along the coastline to speak of. It's really, well, I mean, just a little thin shelf. But and then it gets into clouds. Once you get into the clouds, it's hard to make out. But we can see up until we get to the clouds that that's chunks. And it's big chunks, it's little chunks. It's melted. And that's that older sea ice that they're so upset about. And this part is cloud-free, I believe. Okay, it's over here on this little alley here. And we can see, if the clouds are thin enough, we can see through them. Now look at this area right up here that's so broken up. That's getting into the thinner ice, I'm thinking. We've got a few areas. And you can see the water through there. So I showed the rest of that yesterday. I just wanted to show this portion down here today. Just because the clouds are covering up doesn't mean the ice is coming back all that quickly. And if it comes back, it's going to be very thin because it's a 1-year ice. So that's cloud cover there. And I'll show you the Navy graph for today. This is the Navy computer model for today, the 26th, and we can see that it's still quite thin. It's from a little above 0 to the purple goes up through to 1 meter, and then the dark purple starts at 1 meter, and then the blue is going up from 1 meter, and then the aqua is 2 meters. So that's what we have, and it's this old sea ice is what we're talking about, where there are problems. And it used to be down in all these little cubby holes too, and it's not there anymore. And we can look at their animation, and we can see how it's been deteriorating. And just because it's slowed down up there in the Arctic and we're getting some cooler temperatures, they're still above where they should be, and it's still melting. We're still in the melt season, so we're still going to be watching and tracking this. So I hope you enjoyed the show today. That's all I had to bring to you today. My name is Margo. My website is margoshealingcorner.com. And until next time, God bless everyone. Go in peace. Time is short. Get your spiritual houses in order. And I'll talk to everyone soon. Goodbye.